Okay, let's go to work, guys. I think the first thing I'd like to do is start with that homework that's due for today. Take a look at that and see what kind of questions you have on that. My sense is that some of these problems, it's a little bit hard to know when you have your answer. In other words, when you've gone far enough according to what the direction said. So maybe what we ought to do is just look at that first, see what you have for answers, or see what you have for questions, and then go from there. Now, I've got another handout for tomorrow, right? Is that a different page? Yes, it is. Yep. So I think what I'll do is just start this around, take one of these and pass them on. This is the next ditto homework. There's quite a few problems I'm asking you to do, but they're not terribly difficult, so I don't think it's going to be a big problem. Okay, what questions on the homework due for today? Anybody? Don't just say answers. Do you really let me read the answers? Okay, I will. Okay, now listen, what I'm reading is what the answer book thinks are simplified answers, all right? I'm not sure they're always the best answers, okay? But here goes. What do we have? 1 through 18, 1. A to the x plus y, 2 is 1. Now, I think that is by far the best answer, number 2, because you get p to the 0, and that comes out to be 1. So you really ought to put 1 down as the answer there, okay? Number 3, b to the x minus y. Number 4, r to the 2t. Number 5, c to the w plus t minus v. Number 6, p to the s plus q over q. Hope I read that right, did I? 7, b to the t plus s over s. 8, x to the 2y plus 2z. 9, 1/1000th c to the minus 16. Or put the c to the 16 on the bottom. Number 10, 2/5. Number 11, 4th root of 8. Number 12, 1/9, cube root of 3. Number 13 is 1 again. 14 is 1/4. 15, 1 over 256. Oh, let's see here. 16, 73 over 9. 17, 2, 4th root of 2. 18, 1 over 8 to the 11th. Now what do we have? 23 through 29, is that it? 2840.403. 24, 1.633. 25.909. 26, 2.357. 27, 8 minus 3, cube root of 3. 28, 1 over pi to the 6th. 29, 3a squared. 41 was the easiest one on there. 5.027. What questions do you have? Must be a couple. Go.
Did you 18?
18. Is that one of the ones we worked on a minute ago or not? Is that with the A's on it? A's on it?
Yeah.
Okay, a to the minus 1/3, all that kind of stuff. Is that right? Is that it?
And then
Okay, you want to read it for me, please?
a to the a of 1/3
Over
over a to the 3 halves.
3 halves.
And that's all print.
Okay.
Raised to the 6.
Raised to the 6 like that?
Yep.
Okay. Probably 48 ways of doing this. Now, obviously, we have a lot of work there to do with exponents. There's exponents all over the place. And we need to clean those exponents up. No way is that a simplified answer. What do you want to do first? Your choice.
Well, would you subtract a to the negative 1/3 and then subtract the 3 halves?
Sure, that's okay. So what you're deciding to do is go inside the parentheses and do this operation first, correct?
Yeah.
What operation is indicated there?
Division.
What's the rule of exponents when you divide?
Subtract.
Now, how do you subtract? The top one minus the bottom one, or the other way around?
You subtract the bottom one from the top one.
Fine. So it's minus 1/3 then, minus
3 halves.
3 halves. Sure. What are you going to get for that?
Negative 2/6.
I don't think so. I think that's your mistake right there, isn't it? Is it 4/6? 3 and 6 is 2. 2 and 6 is 3. Isn't that 3? Well, you do it 1/3 here. Minus 3 halves. 6. 2 and 6 is 3. 9. 6. 3 and 6 is 2. They're both, it looks like minus 11/6, doesn't it? Right? That's your mistake then, isn't it? That's
Yeah.
arithmetic error, not an algebra error. Anyways, what we have inside the parentheses right now here is a to the minus 11/6. Now, I still have this, Jeanette, out here. All right? So you said do the division first. Done. Now what do I have to do? No choice now.
Multiply the negative 11/6 by the 6.
Sure, because you've got a power to a power. And what's that rule?
You multiply.
Yeah, what do you get when you multiply?
11.
Yeah, so now I have a to the negative 11th. Now, I don't know what the direction said, but they might have said don't leave a negative exponent. It's a common one, so what's the last step?
1/8.
Yep, 1 over a to the 11th. Everybody like that answer okay?
Yeah.
All right, now, did you have to start that way? No, you could have. Yeah, and what do you mean when you say distributed the 6 through? That's an interesting way to say it, Evan. Great, so you're going to multiply this by 6, and you're going to multiply that by 6. You know, interestingly enough, that might have been easier because you would have gotten rid of the fractions, see? It won't always be that way, but in this one it would, isn't it? 3, 6, it's a minus 2 on the top, 9 on the bottom, see? Then I would bring the 2 down to the bottom, and there I get 1 over a to the 11th on the bottom. Now, it's not always easier one way or the other. In this one, it maybe was. I'm not sure. Okay, though?
Yep.
Good. Go.
27.
27. You read that for me, please? Is this a long one here?
Yeah.
26, 27. Oh, it's that lousy one there. Yeah. Okay, read it for me. Go ahead. Go ahead. A.
Parentheses, 2 to the 3 halves.
Oh, 2? Was it 2? Okay.
Yeah.
2 to the 3 halves.
Plus 3 to the 2/3.
3 to the 2/3.
And then 2 to the 3 halves minus
2 to the 3 halves minus what?
3 to the 2/3.
3 to the 2/3. Okay. Now, I don't know. I guess the first thing you might look at is trying to do something inside this parentheses, a 5 or raising 2 and 3 to that power. I just don't see how you're going to do that. I do not. So what would Jana, what would the first step really have to be here? These the extra ones? Everybody's got a homework sheet? That's exactly what I would do. That's exactly what I would do. Do the FOIL. Okay, now FOIL, first, outside, inside, and last, and I'm not sure that's going to be too difficult to do, is it? Jana, go right here. What do you get?
4, is it 4?
You know that's not. What'd she do wrong? Someone tell her, quick. She did what? And what's she supposed to do, John? Add the exponents and, yeah, drag along the base. Look, what's x squared times x cubed? Yeah, it's not x squared to the 5th. See what I'm saying there? Now, when you did that, you went 2 times 2 is 4, and then 3 halves plus 3 halves. So that's your mistake. What happens, though, Jan? Let's keep going on this, on the foiling. What happens to the middle term? Yeah. So it really makes it pretty easy. I think what you have is 2, then 3 halves plus 3 halves, and then it's going to be a minus 3, isn't it? And 2/3 plus 2/3, and I think it's going to finish easily from there. You probably did a 9, didn't you? Yeah. Everybody understood the mistake she made. Not going to do that now. Very tempting. You know, it's interesting, Janet. You would make that mistake with a number 2, but you would not make that mistake with a variable x. I know it. So use the same with a number that you would with a variable, certainly. Okay, more on the homework. Anything else? Anybody? All set? Good. This is going to make an excellent quiz one of these days. The problem will be, and I understand that, will be how I write the directions. I'll probably say something in the idea of simplify. I might say something about no fractional exponents or all radicals or no negative exponents or something along that order. And what you have to do is try and do all of the operations that I'm indicating so you get down to that correct answer at the end. And I understand sometimes that's a little bit difficult. I understand that. Let's see. I have a little more work I want us to do from the overhead projector. These are equations. And guys, I'm going to ask on these that you not use your calculator, that you do these without the calculator. Probably a little tempting to try and want to do the calculator, but let's not use the calculator at all and see what we get for answers here. I got any luck here. I'll knock this stuff all over the place. You guys see that? How about that? Can you read that okay? There, go. No calculator. Can everybody see it okay, or want to pull it back further? You guys see it up in front? Marcel, you got it? Yeah? That's 3 to the x, and then 3 to the x plus 4. Yep. Also got to read my poor writing there. Now, what I'd like you to do, guys, is to solve these equations without using your calculator. So that again, there's something special about them. They can be done. They can be done. Obviously, what you're solving for is x on each one of these. What I wouldn't do is take the logarithm of both sides. That's calculated. Suppose the question is which class am I going to trip on one of these wires in? That's exactly right. Now finish off and you have it. That quick. Oh, come on. Well, you're saying that if the bases are the same, then the exponents have to be equal, right? So what would you do right here then? I'm surprised. Just solve for x. Just a linear equation from algebra 1. Yeah, it is, sure. Bring the x over here, that's 2x. Take 4 over there, that's minus 4. X equals minus 2, and you're done, out of the problem. Go to the next one. That doesn't get much easier than that, does it? Huh? I guess it is early for them. Well, no, don't. I don't know what that says there. I don't know if I can read that. I wouldn't. Oh, does that say x equals 1?
Yeah.
Is it minus 1, though? Does that say 4x plus 4? Yeah, right? Yep. Nate, now, what's wrong now? Nate, let's look at the first one here. Sure it does. These are easier. Look, these are probably easier than you're making them out to be, all right? Now, Nate, here's what you're not going to do. Take the logarithm of both sides. Now, the problem is you're going to have log 10 in there, and we don't really know those numbers because I'm asking it to be done without a calculator. Now, Nate, if you look on both sides of problem number 1, you have the same base, don't you? Right? The same 3. So it says 3 to some exponent is going to equal to 3 to some exponent. Now, if they're going to be equal, what has to be true about those exponents? Right. So what is true about x and 3x plus 4? They're equals. Now, there's your little equation that you solve. Now, Mike, once you have x equals 3x plus 4, how do you solve that? What you have literally is like a little linear equation there from Algebra 1, don't you? That solves very easily. Now, Nate, that answer that you get is the value of x that will solve this equation, Nate, and you're in business. That's it. And basically, guys, that's the technique you use on all of them. Come on, they were easier than some of the stuff we've been doing. You okay on these? Yep. All set, Todd? Yep. Katie? Got to do a little work on number 4. That's a little better one there. John, okay on these? Yep. Now, where's your answer number 1? Way over there? X equals? Oh, okay. Yep. Marcel? Yep. Okay. Nate, that's okay now, right? Okay? Yep. John, okay? Mike? Now, get a little better when you get down to number 4. Oh, almost number 3, too, huh? Good. That's your answer. Okay. Now, what are you going to do right here now? See, the difference, these problems have the same number on both sides. They don't, do they? But what can you do with this to get it to be a 3? You see what I'm saying? Nikki, okay, all done? Good. Good. And then, Molly, I think it's pretty easy to do. Are they all the right answers? Okay. Yeah, that's good. Nice job. Yeah, that's right. You got to make them the same base. Yes. Now, in some of them, I think you have to make them into the same base. That's going to be the interesting part of it. You got all the right answers? Okay. Jill, you got all the answers, all the right answers, right? Okay. Marcel, where come on, you go for this. Yeah, you don't care that one, I think. Sure you do. Sure. Number 5 is quite similar to number 3, to number 4, I would say. Yeah. Obviously, folks, these are very special equations. I didn't just choose any numbers to put up on there because they work out, in fact, without the calculator. Nikki, what's the key to do number 3? And how do you do that, Nikki?
You see that 3 is a factor or something of 1.7.
So, okay, so?
So you change 1.7 to 3 to the negative third?
Yes. So what you have now, Nikki, is 3 to the x minus 5 equals 3 to the negative third. Did I hear you correctly on that? And then you set x minus 5 equal to negative 3 and you're in business, correct? Now, if you couldn't do that, Nikki, on that problem, this really couldn't be done without a calculator then, could it? Okay, so the key is that I had a 1/27th over there, not a 1/28. 1/28, in fact, would not have worked there. Okay, John, number 4. What was the key in number 4? Bad. Now, here's what I'm hearing you say, John. 3 times 9 to the 2x minus 1. That's what I'm hearing you say. And then my guess is you came down with this as your next step. Folks, he made 2 errors there. Someone tell me what the 2 errors were? I'm suggesting there are 2 errors that he made there. Now, you can see one of them. Okay, what's one of them, Jill?
Multiplying the bases.
Multiplying the bases. Well, what's wrong with that? There you go, order of operation. What's the order of operations tell you?
You have to do exponents first.
And then? And John went the other way around, didn't he? So that's one error that he made. Guys, I think he made another error. What's the other error? Even worse error, as a matter of fact. Say it again. Didn't do the same thing to both sides. Yeah, I heard John say he multiplied the right-hand side by 3. Now, if John had multiplied the right-hand side by 3, what's he have to do to the left-hand side? Yep, got to multiply it by 3 again. And John, now the 27 is getting further away from the 9, and we're not any better. So that does not work. Interestingly enough, John, you do to number 4 what Nikki did to number 3. It's really the same kind of problem, I think. Todd, what's the key on number 4?
You have to use the same base.
And how do you do that?
By going ahead and 1 over 27 equals 1 over 3 to the... Oh,
No, you're looking at the wrong problem there. Haven't you got your own notes there? Come on, what are you doing, Todd? There you go.
3x equals 4x minus
Great. Now, John, he changed 27 to 3 to the 3rd. So now here's your 27. But look at John, there's still another exponent there, and I'm going to put a parentheses in. They're not necessary, but I'm going to write it, okay? And then, John, he did what to the 9? And there's still that 2x minus 1 there. Okay, Todd, what's the rule of exponents right here?
3 to the 3x.
Yes, and what's the rule of exponents right here?
2 times 2 x minus
Yeah, so what do you get? What do you get?
4x minus 2.
That's right, 4x minus 2. And then, John, those get set equal to each other, and we have our value for x. Does that make sense? Okay, Marcel, number 5, the key is? And how do you do that? Okay, and I'm not going to do any factoring. I guess you could talk about a prime factorization problem, but I'm not going to say it that way. What is 8 rewritten as then? 2 to the 3rd, and you have it still to the what? X minus 2? I think I have that right. Okay, and Marcel? 2 to the 4th. And there's your x over there. Now, Marcel, you multiply those and those, correct? Set them equal to each other, and we're done. Does that make sense for everyone? Okay? And what are we on? The last one there, number 6. Nate, what did you do with the 25s in number 6?
I changed the 5.
Great. So the first one was 5 squared, right? To the what? 2x?
4x.
Okay, it'll be 4x. That's right. Then the next one is?
5 to 3x minus 9.
Yep, and I'm going to put it first this way, and then the x minus 3. Good, and then you've already done that next step, Nate, which is to multiply here, right?
Yeah.
Then set them equal to each other, and you have your answers, questions on that. You can obviously see there is going to be a day when there's going to be a quiz, and I will say to you, no calculators. Now, what I'm also saying to you is, look, guys, these are special problems. 25, 125, 8, 16, 3, 27, so on and so forth. Numbers that we can work with. Numbers that we can work with quite easily. If for some reason I make an error on that, that's not going to be a very fair quiz. Make a good quiz, but it won't be a fair quiz. Okay, we're done here. Now, we ought to be ready to do this too, I think. This is what I'd like you to try and do now for me. And I don't know, without looking around in your book for some kind of an answer, and without really for a moment or two asking me any questions, sketch a graph for me of the log function. Yes, I am. Sketch a graph of the log function. Now, you've got to be able to convince me of it. Okay? Sketch a graph of the log function. Yeah, you know you can. Yes. Who asked me that? That's a good question. Yeah, go right ahead and use your calculator. As a matter of fact, I guess I would encourage you to use your calculator, except for that graphing calculator, Casey and John. Now, go ahead and use your calculator, but don't use the graphing. Don't use the graphing part of it. Yeah, it is neato.